Welcome back to Dethernety. In our previous videos, we built threat models the traditional way, manually dragging components, drawing data flows, configuring controls by hand. It works, but it's time-consuming and quickly becomes outdated. Today, I'll show you a completely different approach. Using AI agents with MCP integration, we'll go from architecture diagrams to fully enriched threat models with real infrastructure data. AI agents can generate threat models from multiple sources. Structured data like draw.io diagrams, Archimate Open Exchange format, Terraform or Kubernetes manifests work perfectly. The agent parses them directly. But here's what's remarkable. Even from a simple PNG screenshot of an architecture diagram, the AI can understand the architecture, identify components, and create a complete threat model. That's what we'll demonstrate first. Here's a screenshot of our DevOps platform architecture in Archimate format. I'll ask the AI agent to create a threat model from this image and save it to a file. Watch as the AI analyzes the visual. It identifies the Jenkins CI/CD pipelines, Vault for secrets management, Kubernetes platform with cross-plane for infrastructure provisioning, container runtime workers, and Nexus artifact repository. It recognizes the security boundaries and deployment pipeline flows. The AI composes a complete Dethernety structure with proper component types, boundaries, and data flows. I'm saving this to a file. And this is key. Because it's a plain JSON file, we can commit it to Git for version control, back it up with our infrastructure code, and easily test different security configurations. Now, I'll ask it to import this model to Dethernety, and here's the result. Look at this. The AI has created the complete data flow model with all the security boundaries properly defined, components positioned logically, data flows connecting the pipeline stages, and it's even intelligently identified data assets like Helm charts, deployment configurations, secrets from Vault, and artifacts from Nexus. All of this from a single screenshot. Now let's discover actual infrastructure. I have a demo e-commerce deployment running in Kubernetes. And before we start, an important security note. This is a test environment. Never perform automated discovery on production systems. If you must access production, ask the AI to generate an offline script that you can review and execute, and use the output to feed the agent for the data flow model. The AI executes kubectl commands to gather deployments, services, network policies, and ingress configurations. It identifies the storefront nginx deployment, the identity and checkout services, the PostgreSQL database, the Redis cache, and the payment gateway. Notice how it maps Kubernetes resources to threat model elements. Deployments become process components. Services define data flows. Network policies map to security boundaries. And ingress controllers show external exposure. The resulting JSON file contains our complete infrastructure topology with real configuration data. This becomes our living documentation that evolves with the infrastructure. Let me check the model in Dethernety, and I notice something wrong. The AI created the default boundary as Kubernetes cluster with internet as a child boundary. That doesn't make sense. The internet shouldn't be inside the Kubernetes cluster. Here's the beauty of this workflow. I can simply tell the AI what's wrong. Please fix this by making Kubernetes boundary only as parent of the namespaces. This demonstrates iterative refinement. The AI isn't perfect, but it can quickly understand corrections and update the model. This is how real threat modeling works. Discover, review, refine, repeat. Now, let's enrich our model with Dethernety classes. I'll ask the AI to identify the most appropriate classes and update the file. The AI queries the Dethernety platform for available classes, analyzes each component's characteristics, and assigns the best match. The storefront gets the nginx web server class, APIs get REST service classes, and the database gets the PostgreSQL class. These classes bring built-in security policies. exposure detection rules, and MITRE attack mappings. The AI updates our JSON file and uploads it to the platform. Let's go deeper with attribute enrichment. For the storefront component, I'll ask what security attributes we should capture. The AI queries the Dethernety platform for the ngNext class definition from the module. The module defines exactly which attributes this class requires: open ports, protocols, TLS configuration, authentication methods, and network exposure. These aren't random attributes. They're deterministic, defined by the module to enable automatic exposure calculation. The AI then queries the actual Kubernetes deployment to gather the real values for these specific attributes. The AI updates our JSON file with these real configuration values and syncs to the platform. Now here's the power. With these complete module-defined attributes set, Dethernety calculates security exposures, detecting exposure risks, analyzing attack vectors, and providing specific recommendations. The modules know exactly how to interpret these attributes for security analysis. Let me enhance this model further. In Kubernetes, processes run inside pods, and pods are important security boundaries. I'll ask the AI to add pod boundaries around the processes. The AI queries Dethernety for the Kubernetes pod class from the platform's module library, then analyzes the model structure to identify all processes running in the cluster: the storefront web server, identity service, checkout service, PostgreSQL database, and Redis cache. Watch as it extends the model by wrapping each of these components in a pod boundary. This creates a more accurate representation of the Kubernetes security architecture. Each pod is an isolation boundary with its own network namespace and security context. This demonstrates progressive enhancement. We started with basic infrastructure discovery, corrected structural issues, assigned classes, enriched with attributes, and now we're adding finer-grained security boundaries. Each step makes the threat model more accurate and the security analysis more precise. Look at this journey. We started with a PNG screenshot, discovered live Kubernetes infrastructure, corrected structural issues with natural language, assigned security classes, enriched with real configuration attributes, and added fine-grained pod boundaries, all through conversational interaction with AI. This is modern threat modeling. Iterative, intelligent, continuously refined, and integrated into your DevSecOps workflow. This is the power of Deternety's AI-powered workflow.